With this video, we shall demonstrate the second Ziegler-Nichols method, which is called oscillation method, for the tuning of PID controller parameters. In comparison with process reaction curve method, this is closed loop method. This closed loop situation is in this program obtained with this parameter main loop equals 1. This means that this main loop is active. On the other hand, the initial values of parameters are Kp equals 1, Ti has at the beginning a very high value and Td equals 0, so only the P controller is active in this part. On the other hand, the auxiliary loop is not active because this parameter equals 0 and the auxiliary controller gain equals 1. So we use only the P controller in this experiment. In the sequential experiments, the controller gain is increased till the oscillation of the controlled variable with constant amplitude is achieved. However, it is possible only for at least third-order proportional and integral processes or for the lower-order processes with a dead time. With this for-and loop, we successively increase the gain of the main controller. So we select actually the values from 3 with the steps 3 and the final value is 9. We simulate our Simulink scheme. The simulation time is the final. We obtain the vector t. This is the vector of independent variable. These are states and these are outputs. And in the figure 2, we plot several curves. This is actually one curve is Y3. This means the third output. The third output is the reference signal. And this is plotted with black color. And we plot also the second output. The second output is the process output. This is the level course. And this is plotted with red color. We also put here the command hold on. This command means that the next plot in this loop will plot the curves into the same window. We define also the title of the main plot window. If we want to execute this part of the program, we select this part and press F9. And so we obtain this level course for the gain 3, for the gain 6, and for the gain 9. We can notice that the gain 9 gives the oscillations with the constant amplitude. This means that we have the situation on the stability limit. If we should increase the gain, the results would become unstable. From these responses, we calculate the following characteristic values. We notice that the critical gain is 9 because an increased number would cause unstable behavior. Then we must also determine the critical period. This is the time, for example, between this point and this point. The critical period is 28.2. With critical gain and critical period, we determine the parameters of P, PI, and PID controllers according to Ziegler-Nichols rules.